Great. So everybody, welcome. Thanks for joining us. I'm Ken Wallens. I'm with Findability Sciences, and today we are going to talk about payment propensity. And I see in our audience today that we've really got a great mix of businesses represented. We've got primarily financial and retail companies. We also have some RCM and healthcare. Hang on just a moment. Welcome. And overall what we're seeing today is it's really interesting. We're seeing that businesses today are really all over the map when it comes to making use of artificial intelligence. And there have also really been mixed results in terms of really being able to extract a benefit from it. It might be comforting to you, depending on where you are.
Join the meeting.
To know that even some of the largest banks are having difficulty establishing a competency around artificial intelligence. And so our discussion today and the demo that we'll follow will focus around how artificial intelligence can be applied to enhance collections easily and quickly. And just give me a moment here as I let some more people in. Welcome, everyone. And so again, just to kind of recap, so today what we're going to do is show businesses really how they can benefit without having to make a significant investment in technology or personnel or in maintenance of the technology. You'll see a platform that's versatile. And as an example, with different data sets, we're going to talk a lot about data today. You can run other use cases that can be deployed pretty easily, whether it's for churn analysis, for example, predicting default or fraud risk, or for marketing purposes. And so with that, just a few quick housekeeping items. Again, I'm going to try and have everyone's audio muted. And if you can mute your mics on your own, if you see that it's not, I'd appreciate that. We will unmute at the end for Q&A. And if you have questions in the meantime, please feel free to submit them during the presentation with your chat window. And now I just want to introduce our speakers. So Madhuri is a principal consultant at InGroup Consulting, and she has years of experience at major firms like Intelenet and Serco and HCL. And Sanjay is our resident banking specialist and is a senior vice president here with us at Findability Sciences. And he has served in executive roles at Citi and at Oracle. And so with that, I'd like to turn things over to Madhuri.
Thank you, Ken. Good morning, everyone. It's a great pleasure that I get this time with you guys as the audience to strike a conversation on artificial intelligence, predict propensity to pay. That's the topic for the day. But just before we get into the thick of things here, I thought we'll do a little context setting and get you to get a view by saying what the debt collection world looks like. Why predict propensity to pay matters to us. So I'm here on slide 1, which says U.S. consumer debt scenario and stats. Take a look at this. It says that there's about 13.3 trillion by the end of 2018. Like this one, it's about 14 in the first quarter of 2019. I want to step back a little bit more and look at what the market looks like in this context.
Join the meeting.
It's 189 trillion, and that's like huge. It's like a debt mountain that the whole world is tackling. Thankfully, it's not just on consumer debt. It's a mix of public and private. When you look at, and then you see that, okay, who are the principal borrowers? And if you look here, it is the economies that are flourishing well, and those are the ones that contribute to the debt is U.S. You've got China and Japan. 3 put together own more than half of the global debt market today. Now zoom back into by saying that what is it that U.S. has as part of the consumer debt here, and we're looking at 14 trillion. Okay. Some stats here that says that what's this average debt per age that we've got. But more than that, what I want you to just focus and stay with me for a bit is before we get the graph here. Let's look what else does this market comprise of. When you look at 13.3 trillion or 14 trillion being there out for as in the debt market, almost 5% of this, as we speak, sits in a delinquent state, which means that about 650 billion odd is a debt collection portfolio that's sitting somewhere, needs everybody's attention on it. And pretty much out of that 650 billion, a cool 23% goes to the collection agencies for collection, and it sits anywhere under like a 90-day bucket. So it's important when we understand by saying what's there in terms of context. And now let's look at this graph that's here. It's getting more and more important these days that any data that we look at, start looking at it by saying that let's look who owns this. And it's not about just general demographics and saying where this debt sits. The large buckets, and for people in United States, we all know that debt, the way that it's configured currently is about the major portion that's there is with mortgages. The next big loan bucket that's there is student loans. That's always on the rise.
Madhuri, I just want to interrupt really quickly. I think there's some difficulty with your audio, so if you could perhaps speak a little bit closer to the microphone.
Okay. Am I audible now?
That's great. Perfect. Thank you.
Okay. All right. Just tell me, Ken, when I'm not audible. I usually have like a big...
Will do. Yeah, you sound very clear right now. Thanks.
Okay, great. Focus back onto this graph that we've got here. And what I was trying to say is looking at those big buckets that are there for collections, mortgages, always a case for concern, followed by student loans, credit cards, and healthcare. Like this portfolio, when you look what's there in the 90-day delinquent bucket, typically of the total debt, you will see mortgages hovering between 2 to 3%, cards between 8 to 9%, auto loans anywhere between 3 to 4%, student loans almost like at about 12%. So these are like big stats. I know that these seem like random stats that we're probably talking, but they all
join the meeting.
Here. And now, again, back to where I said that what matters is we looked at these buckets, but look at who owns them. And every conversation these days of late that I'm having is revolving around customer segmentation and more by generation, by saying who owns this. And the big buckets, Gen X's, maybe people like me who own the bigger piece of the mortgage kind of a loan, and Gen Z's, which are getting into the student loan bracket that you're seeing here. And of course, it staves off as you see the earlier generations where the mortgages, and obviously there are no student loans that are there. But at any given point in time, and about 14% of the American population has one debt or the other that's there out for collection. Some of stats on the right where you're seeing, and I think I spoke about mortgage, credit cards, and student loans, medical expenses. This is like a big one. Ideally, I don't want to, give any time to any of these particular segments because each of these standalone are large topics. Let me take you to, so what happens now? This is the overall debt scenario. I want to give some attention of saying what's happening in terms of the debt collection trends and collection practices. For most of us folks who are there on this call and at some point in time are currently managing collections or receivables management or debt management, whatever we would call it as a head, it's of interest. And for me, that I've been there for long enough in this space, started out pretty early. And if you see, there's a certain evolution to it. We all know that how portfolios ran and what those traditional practices have been. We have a set way of running a dialer strategy, their collection strategies, you segment your portfolios. And you feel like really pretty confident when you own this portfolio and you say that this is a right way that I can get a good hit rate on whether, in terms of your customer contacts, or that you have like an algorithm around the payment size that you wanted to run with, different combinations. And these are all traditional methods of debt collection, which involves the way that we wanted to reach our customers, so whether it's by mail or uh, can I look at you, and I hope I'm audible when you just move forward. Okay. Um,
Thank you.
and and then we get to the dialer strategy, which evolved, and we felt like pretty good even in that space, where we moved from multiple scenarios of saying right to the time where we said automated calling was prominent, and we know how we prioritized the payment segments. When we say that, let's understand what's this impact when we say of this context. About 1 billion contacts are just made each year uh, on account of collections. Now, these are all the traditional practices. But what we're seeing, there's an interesting stat. I hope you're able to read this, which says that the debt collectors, we're seeing that the total recoverables that are there are slightly declining. And why is this? That's because our practices have been the same. Our consumers are different. The economy game is changing, and the way that we are borrowing and the way that we are repaying are all changing. But our methods have still been the same. So we're saying that there's probably a time for us to look at what's the next phase for us, and that was the evolution of automation. And again, people have been here in this space for some time. I want to say that this must have been our most favorite part of saying we've automated a lot of piece of this work in collections. And when you get there, yes, and I've been there too. Used to be an early coder in the days of COBOL, and my first programming routine was around collections. So I used to feel like, this is like really automation that we've gotten in here. By the time we came down to GE and we created what was called like an account prioritizer, an engine, then we felt like this is like a major breakthrough in the way that we were looking at it. I'm speaking of B2B kind of collection portfolios and large portfolios. So the way that we prioritize and we build this algorithm, we thought this is like a greater level of automation that we've secured here, and we have like a great line of control in terms of what we want to do for this portfolio. But mind we do some of these things, campaigns that we build are probably not strong enough to last us during the seasons or with the changing portfolios. So there is the next one. The way that hits all of us is the rise of the AI, as I call it here. And look at what is the future of debt collections. In fact, I was reading something that says AI is the new debt collector, which is pretty interesting for us to read that. But what AI is striving to do is we're moving away. Again, we're going back to consumer conversations, and where we predominantly just refer to them as debtors. We are coming back to calling them as consumers, and we want to create customer experience even in debt collections, which was earlier unheard of during our traditional methods. So now where we are in terms of AI applications, major things that we can look at. On the right-hand side, if you see, is the way that we are trying to an outreach program in terms of our contacts, in terms of our tailored conversations that we want to have. And then there is also, the ratio of debt that we could recover from a cure ratios that we want to do. But most important, I want to focus what's for our topic here is the propensity to pay. That takes us by saying that are we all geared enough when we're looking at AI and propensity to pay? I quickly want to get your attention to see what are the top 10 data analytics and technology trends. And here's just a snapshot, not going into any of these in great detail, but just for you to know what are those top 10 here. But of those, the top 3, which is analytics, data management, and like a continuous intelligence around the AI involvement in this particular segment, is what gets us to the conversation for the day, which is AI and the propensity to pay. At this point in time, I think, Sanjay, I will request you to lead the next set of the conversation for us.
Thank you. I think you can stop sharing your screen, Madhuri, and then I can take the control here. So these are the top 3 trends in AI, and which are listed by Gartner in 2019. And the top trend is augmented analytics. Second is augmented data management, and third is continuous intelligence. So all of these trends are something which are already being practiced, and findability science is here. We have a propensity solution in which we have already incorporated these trends. So I'm really focus today on the propensity to pay solution that we have developed, and I'm also going to show you a demonstration for credit card payment propensity as an application. Unfortunately, the implementation of a very powerful AI-based payment propensity doesn't have to be complicated. It's fairly simple process to do. It's quick and it yields results. What payment propensity really enables you is, when we model it, you can score the payment propensity, your account receivables portfolio very accurately, and that helps you for a much better and more efficient and productive targeting of the portfolio for a better recovery. We have observed uplift for our clients, which are BPO companies, which are applying it for healthcare collections, credit cards, as well as banking debt collections. And they have observed uplift of 30 to 40% at a reduced capacity. It's also a turnkey solution. So after the initial modeling is completed, we just have to ingest the data into the platform, and it develops models automatically and scores your portfolio for propensity very accurately. You don't need any programming. Data scientists are also not required, and it can be handled by the business and operations in your company. It's cross-industry. The solution is applicable to banks, healthcare, insurance, retail, and basically any debt collection portfolio. And this propensity solution is also applicable to other than debt, which is, for example, lead conversion propensity or propensity to fraud and other types of propensity solutions as well. So today I'm going to show you the solution for as applied to a credit card payment propensity. And what I'm going to show you the typical data set that we work with. So some of the features that are available in this data set are listed here, such as gross amount, history of payment, billing cycle, employment type, and salary income. And once this data is made available, then we put it into Findability Platform, which is an AI-based solution that we have developed. The key features of this are it is self-learning. What we mean by self-learning is once we ingest the data into the platform, then it scans the data, it identifies all the patterns which are inherent in the data set, and it learns on its own, and it develops models for every distinct pattern that it is able to identify within the data set. And the entire modeling process as well as the scoring process is completely automated, which is what I will demonstrate to you in a moment. The result of this process is that we produce a payment propensity score. So every record in your accounts receivables portfolio gets scored with a payment propensity. So payment propensity is really the probability or the level of confidence with which you can recover. What is the chance of recovery of the payment within a given time frame? Once this payment propensity score is made available to you, it is typically programmed into a programmable dialer, which a call center or a recovery center or an operations center uses to really prioritize the collection efforts. And overall, this results in improved collection. And the benefit that we have observed is the collection yield has increased by anywhere between 30 to 40% as a result of application of the payment propensity solution. So once we have the propensity score, how do we operationalize artificial intelligence based debt collection strategy? So first step is, of course, the advanced predictive model, which I just mentioned, where once we have scored the payment propensity for each record in your data set, then we classify it into high, medium, and low propensity to pay. Then the next step is doing a materiality analysis in terms of the outstanding amount, which is again classified into high balance, medium balance, and low balance. By combining both these payment propensity to pay and outstanding amount, then the operational strategy is formulated. So for example, for high propensity and high amount, an accelerated collection effort can be designed. Whereas for low propensity and the low amount, minimum or no collection effort is required. Based on this, you can form your operation strategy, such as what channel to reach your consumers, what is the frequency of contact, and monitor the collection results versus the efforts. Finally, effort optimization. So based on the strategy that you have implemented, you can use your capacity of the agents, the debt collection agents, based on their skills and experience, and allocate appropriate agents to the type of collection efforts that you need to put into. This overall helps you to optimize your attempt as well as the contact intensity, and with less effort and less capacity, you can improve your collections. So this results into higher collection yields and while reducing the efforts at the same time. So typical way of operationalizing the strategy is you divide the propensity to pay into high, medium, and low balances. And outstanding balances are divided into low, medium, and high. And for high propensity, for example, you can have a differentiated strategy. So for high propensity as well as high balance, you have accelerated collection efforts. Whereas for high propensity and low
Sanjay,
balance,
sorry, the audio is fading just a little bit, so.
Okay, I'll speak louder. Thank you, Ken. So for high propensity and low balance, you can apply only minimum collection efforts. So similarly, you can have a very targeted strategy of collections depending on a 3x3 matrix of propensity to pay versus outstanding balances, and tailor your strategy for improved collections and more productive results. So after this, I'm going to show you a live demonstration of our propensity solution, which is for credit card payment propensity. So I'm going to open my browser here and click on this FP propensity solution. So Ken, are you able to see my screen?
Yes.
All right. So I'm going to log in here. And this shows some of the earlier batches that we have already completed. And I'm going to start a new batch for predicting propensity on a debt portfolio of credit card collections. So before I get into this screen, I'm going to also bring up the data set here. So this is this data set. This is the batch on which I'm going to run the prediction, propensity prediction, and this has about 6,350 credit cards, which are uniquely identified by this identifier. And I'm going to predict the target variable, which takes two values: RF, which is it's not paid and it's rolled forward to the next bucket of aging, and PD, which is paid. So those credit cards which are going to get paid in the next 30 days are classified as PD. So this is the target variable takes two values. So this is a binary prediction, and these are the other variables in terms of credit trails, the amount of balance, and the balance bucketing, etc. So this is about 25 odd variables. So now after this, I'm going to start a new batch for collection to predict payment propensity. So I'm going to start by uploading the historical data. Historical data is really use for learning the patterns in the data set, and where the previous outcomes of the target variables are already known. So using this data set, historical data set, the system is going to do the self-learning and develop the models automatically. After this, I'm going to upload the prediction data set, where we are going to run the propensity prediction. And then we have to just select what is the target variable, which in this case is historical payment status, whether it is paid or not paid. And it's possible to predict propensity either for TD, which is paid, or roll forward. So I'm going to select TD and predict for that. And for every transaction, I also need to select what is the unique transaction identifier, which I'm going to select here as identifier. And then I have to select the column which defines the balance payment, which is this balance amount. So it's as simple as this, and it is now, the prediction job is now ready to be started. So I'm going to just click predict here. And then it's going to upload the historical data. The historical data consists of about 25,000 odd records here, which are used for training, and it has a pattern which is very similar to the prediction data set, which is here. So this prediction data set is having about 6,350 records, and about 70% of these cards had got paid, and about 30% of these cards had got rolled forward, or they did not get paid within the due date of 30 days. So right now I'm coming back to the screen, and this is the training file is being submitted to the prediction engine, where it's now analyzing the patterns and developing the models. This process will take about 2 or 3 minutes, because this is having about, between the training file and the prediction file, it's a fairly large data set, almost 30,000 records, but that will get processed in about 2 or 3 minutes. So while this job is running, I just want to again highlight that it's a self-learning system. It's also called as automated machine learning. So it's we don't need any data scientist, or no programming or R or Python is needed to develop models. Secondly, it's going to develop multiple models, and you will see in the screen as it develops different models, and it will keep showing notifications as it develops newer and newer models. And third is the scoring process. The propensity scoring is also completely automated. So every model that was generated using, so right now it is finding the patterns. So and it started creating the models. So you can see here that 1 model, 2 models, 3 models, 6 models are getting created, and they are getting created very, very quickly. So this will develop about, for this data set, about maybe 20 different models. So now it has already created those models, and it is archiving those models. And it has now started calculating the propensity. So it is applying those models to the prediction data set and generating the propensity scores. So the job has got completed, and I'm going to close this window now. All right, so So this is the propensity output that it has produced. You can see here that the payment propensity is classified into three categories: high, medium, and low. And the balance amount is also categorized into low, medium, and high. So you can see here that in the high propensity and high balance, there are 116 records. So if I click here, then all of those records, the ID, individual ID, what is a propensity class, what is a propensity score, and what is a balance amount. So that will be listed here, and all these are sorted in the high to low order of propensity. Here, if I click the mouse here, then it shows the appropriate strategy such as focused collection effort. And if I go here, low propensity and low balance, then it shows a low priority. And I can click here and see all the accounts which are listed here, which are in the category of low propensity class as well as the low propensity score. I can go here and see the detailed results. So here is where you get to see the entire portfolio, which has been ranked in the order of propensity along with the amount. So I can go down and see that the propensity score is classified into high, medium, and low classes with the appropriate propensity score, which is sorted in the order of high to low propensity and the corresponding amount. So this is a simple result that you get, which can then be merged with your original data set, and a propensity-based strategy can be applied to use your predictive dialer using these propensity scores. For more detailed analytics, which may be of interest to the data scientists within your teams, we can download the analytics here. So this shows the type of job that we run. So training file had about 22,000 records. The prediction dataset had 6,000 odd records, and the prediction results are listed here. So every account we are predicting for whether a particular card will get paid or not. What is the model number that was used to score that particular record? And you can see the different models are being used to score different records. And the propensity score is available here. And there is this decile which tells you whether it's in the top decile or which decile. So if I go down here, then you can see the entire portfolio which is scored for the propensity score. When I go into this predicted versus actual, so here is where we have divided the entire portfolio into 10 buckets of 10% each, called as decile. So altogether we had about 6,350 records, and the random probability of any card getting paid was about 70%. But when we have given a propensity score and rearrange the entire portfolio into an order of high to low order of propensity, then we are getting a predicted probability in the top decile of 94% as against 70%. And we are finding that there are about 610 cards out of 636 here that got paid. So which means that we are getting a hit percentage, or we are identifying almost 95% of the cards which will get paid and bringing them into the top decile, which is giving us a lift of 1.37 or 37% in the top decile. So the top three deciles are your high probability deciles. The next four deciles are your medium probability deciles, and the last three deciles are your low probability deciles. So this really allows you to get an accurate propensity score, and the operation strategy that I mentioned can then be tailored according to the propensity score. So here is where we see all the different multiple models that got generated. So model number M1 was used to score 2,200 records. Model M8 was used to score 917 records. This also shows you all the variables that were used in different models. And this shows which model used which variable. So there is analytics available for to identify which are those variables which were used in predicting the propensity score. So with this, the demo is done. Let me just move on to give you a quick introduction of Findability Platform, which enables this FP propensity solution here. So we have the big data layer, which is really where it connects to multiple sources. We can handle both structured data, unstructured data, and bring it all together so that our solution is AI ready. And FP cognition, so wherever there is unstructured data, we can process that for conversational computing as well as for tone and sentiment and for data enrichment purposes. And then we have the FP credit layer. So FP propensity is a specific solution based on FP credit platform, which is used to score credit card balances, propensity to pay health insurance claims, propensity to fraud, lead conversion to customers in marketing, as well as propensity to churn. So we have different models for engagement. We offer a full service model where we can provide a turnkey service handling end-to-end solution for you in terms of handling your data as well as providing you the propensity output. Or this platform, the solution can be licensed by you and it can be installed on-premise so that your business or your operations can directly implement it and use it. And third is for a service providers such as BPO and contact centers. We can also offer it as an embedded solution as a part of your overall flow. A quick introduction to Findability Sciences. We are a SoftBank portfolio company. We also have a joint venture with SoftBank. We have also been a founding member of advisory board of IBM Watson, and we have invested in Soften as well as Workfront AI, which are in the fields of AI predictions as well as RPA. We are present in Boston, Tokyo, Toronto, Mumbai, and Aurangabad. So with that, I have completed this. I think we just have about 5 or 6 minutes left for Q&A, Ken. So have you got any questions?
Thanks, Sanjay. I've just unmuted everybody. So why don't we do this? If you have questions now, we can listen to those. I've also received some questions by chat that I can submit to you separately, Sanjay.
Okay.
So would anyone like to raise their hand with any questions? Anybody?
People still there?
We've still got a bunch. It's 30 plus, so. Well, great. So let me take a look here. So I have a Q&A from the chat, and it says, how do you handle data security?
I think the data security, Ken, is very important. And I think when we deal with our clients, I think data is an asset and there is confidentiality of the data, and everybody is quite concerned about how we handle data. And I think there are various ways of handling it. And first of all, the solution is also available.
This IBM thing, that's really your number one. That's what you're focused on.
Which one?
The IBM OEM relationship. That's all you're doing.
OEM relationship, and then the data first, and then like everything IBM. Internally, externally.
Okay, there is some crosstalk. So yeah, I mean, so we can do this as an on-premise installation. If it's in the client prefers cloud, then it's available as a private cloud. We generally prefer IBM Cloud, where we have a strong relationship with IBM. And there are multiple options in terms of masking the data and making changes to it so that without losing the integrity, it's possible to process it so that the confidential information is still protected and the risk can still be managed. Can you run mute?
So another question is, how are benefits to the customer measured? And I'm not sure if that's in terms of ROI. We can talk about that as it relates to the pricing that we offer, the licensing, what have you. Sanjay?
Right. So I think, this is, I think when it comes to debt collections, that's a very, very measurable process. So, whatever the customer already has historical rates at which he is able to collect. And what the customer is really looking at is, what kind of uplift that they are able to get in terms of collections with the same capacity or less capacity. So we can, first of all, provide a test on the historical data where we show the uplift. And then we implement this process in parallel with their existing process and demonstrable results in terms of uplift for customers who desire it. So we are quite confident of the uplift that we are able to provide and the customer benefit, so that we can price it based on a share of customer benefit. And if the customer is not going to benefit, then no charge to the customer for our services. So there are very clearly measurable benefits can be provided using this solution.
Okay, great. And so thanks, Sanjay, for that. By the way, I've put everyone back on mute just because we had some problems with some feedback. So I have a question to submit, and I guess pending that, if there are no more questions, we can close out after that. And so Sanjay, you talked about the predictive models that are created. So I have kind of a two-part questions. Based on the number of models that are created, can you give us kind of a contrast in what it would take for that to be done manually by a team of data scientists and the practicality of updating those models? And then the second part of that is, how frequently can we update our predictive models for the particular use case that you talked about just now with collections?
So first of all, I think, we encounter, when we go and talk to clients, what we observed is, there is a team of data scientists and some existing solutions which are already there. And most of these have taken, anywhere between 6 months to 12 months to develop. And there is a human bias in developing those models. And once those models are developed, then, there is some kind of affinity to those models and resistance to change those, even if those models are no longer effective. Whereas when we implement this solution, the entire modeling process is automated. So, it's really a question of doing revalidations with your data, and I think the models are ready. They are actually produced on the fly, but we need to test the data with your data, and that can take just a couple of weeks within which our models are ready to be implemented. And once the initial modeling process is done and implemented, then the refresh is automated. So as you collect newer and newer data, historical data, that becomes, we just feed into our models and the models are refreshed automatically. So really this solution keeps current with underlying changes or underlying trends in a data set. It identifies those patterns, the newer patterns automatically, and refreshes itself on the go. So it's possible to do it either monthly or weekly or as frequently as daily refresh is possible.
Okay, excellent. Well, great. It looks like there are no other questions, and so we can close out. And it looks like we're right on time with our scheduled time here. I want to thank everybody for taking the time to join us. If you have any questions, you can see my email address WKEN, at findabilitysciences.com. I would love to talk with you about the business plans that you have and give you the opportunity to try us out. So thanks, everyone.
Thank you.
Thank you.